Okay, now let us do the problem. Find the half range sine series expansion of f of x is equal to x square in 0 comma 4. Okay, since it is mentioned clearly half range sine series. Okay, half range sine series expansion of f of x is equal to x square in 0 comma 4. Okay, 0 comma 4. Now the given function is f of x is equal to x square interval 0 comma 4. So now compare this interval with the 0 comma L, half range. Okay, half range 0 comma L. So here L is equal to 4. We have the half range sine series formula. F of x is equal to x square sigma n is equal to 1 to infinity bn sin n pi x by L. I told you half range sine series contains only sine terms. That is the formula here. Sigma n is equal to 1 to infinity bn sin n pi x by L. Here L is equal to 4, we know that. Now bn is equal to what here? 2 by L. Bn formula. Bn is equal to 2 by L integral 0 to L f of x sin n pi x by L dx. Okay. Since L is equal to 4, put L is equal to 4 here. 2 by 4, 0 to 4, x square sin n pi x by 4 dx. Now integrating by parts. Okay, using Bernoulli's rule, we can integrate this. Integrate by parts. This is u and this is v. U into integral v. That is minus cos n pi x by 4 by n pi by 4 minus the derivative of x square 2x and the integration of this whole thing. Okay, integration of this. So that is the integration of this is minus sin n pi x by 4 by n square by 16 plus what is the derivative of this? 2. Okay, and integration of this is cos n pi x by 4 by n cube pi cube by 64 from the limit 0 to 4. Okay, now here 1 by 2. Yeah, so if I take this upper limit 4 in place of x, so what I'll get here minus 4 by n pi 16 into cos n pi plus similarly if we take the upper limit there 32 by n square pi square 4 sin n pi and 2 into 64 by n cube pi cube cos n pi. Okay, and now similarly if you take the lower limit also, so there you will get this minus 128 by n cube pi cube. So this is the term you will get by taking the upper limit and the lower limit 4 and the 0 in this if we take this. Okay, now since we know that cos n pi is minus 1 whole power n, yeah, and minus into minus 1 whole power n is minus 1 whole power n plus 1. 4 into 16 64. Here 432 is 128 and you know the sin n pi is 0. Yeah, sin n pi is 0. So this term is 0. Now here again here 264 is 128 cos n pi is minus 1 whole power n 128 by n cube pi cube. Next minus 128 by n cube pi cube. Okay, now what you can take the common here, 64 we can take the common and 2 64 32, so you get cancel here. Now we can take this common from this n cube pi cube. Okay, we can take the common here and we will get this minus 1 whole power n plus 1 by n pi. Okay, minus 1 whole power n plus 1 by n pi. So this is what the bn we got, and the bn depends on minus 32 by n pi when n is even. When n is even numbers, we will get the bn as minus 32 by n pi. When n is odd, we will get 32 into minus 4 by n cube pi cube plus 1 by n pi. So this is that depends on the n value, we will get the two different values of bn. Okay, by substituting this bn in this 1, we will get the required Fourier series. That is sigma n is equal to here for evens and for odd ones. Yeah, and even ones and odd ones, we got two different bn values. By taking in this, we will get minus 32 by n pi sin n pi x by 4 plus 32 into sigma n is equal to for odd ones minus 4 by n cube pi cube plus 1 by n pi into sin n pi x by 4. Okay, so this is the half range sine series of the given function f of x is equal to x square in the interval 0 comma 4. Now let us take a look at another problem. Here find the half range cosine series expansion of f of x is equal to x. Okay, f of x is equal to x in 0 comma 2. Okay, this is half range cosine series. It's clearly mentioned it is half range cosine series. Half range cosine or cosine series, both are same. Just you have to go with half range cosine only. Find the half range cosine series expansion or find the half range cosine series expansion. Or if we half range doesn't mention in the problem, still we have to go with this half range cosine series expansion of f of x. Okay, here given f of x is x and it is asking the half range Fourier cosine series. So the series must contain only cosine terms. So that is f of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity a n cos n by x by L. Okay, and here you know that what is L? If you compare the given interval with 0 comma L, so we will know that L is equal to 2. Now a naught is equal to 2 by L integral 0 to L f of x dx. So L is 2, so take the put 2 here and 2 get cancelled, 0 to 2 x dx. Integration of x is x square by 2. Taking the upper and the lower limit, a naught is equal to 2. Now a n 2 by L integral 0 to L f of x cos n by x by 2 dx. Okay, cos n by x by 2. Here L is 2, so I just taken here already. Now in the next step I am taking L is equal to here 2 by 2 integral 0 to 2 x cos n by x by 2 dx. Okay, 2 to get cancelled, and now integrating by parts. X u is x and v is this, yeah, u into integration of this sin n by x by 2 by n pi by 2 plus derivative of x is 1 integration of this. Okay, integration of this we are taking this minus becomes plus. Okay, I took it out. Cos n pi x by 2 by n square pi square by 4 from the limit 0 to 2. If we take the upper and the lower limit, I'll get this term cos n pi minus 1 by n square pi square by 4. Since we know that cos n pi is minus 1 whole power n. So now, so here 4 by n square pi square into minus 1 whole power n minus 1. Now again we'll get the n value, depends on the n value, we'll get two different values. That when n is even, an is 0. When n is odd, an is minus 8 by n square pi square. Okay, now substituting the values a0 and an in 1, so now we get x is equal to 1 minus 8 by pi square sigma n is equal for odd ones. Odd ones only the value exists 1, 3, 5. For evens that is 0. An value is 0. Okay, that is 1 by n square cos n by x by 2. If you take the odd values in place of n 1, 3, 5 like that, I will get this expansion 1 minus 8 by pi square into cos pi x by 2 plus 1 by 3 square cos 3 pi x by 2 plus 1 by 5 square cos 5 pi x by 2 plus so on. Okay, so this is which is the required Fourier series. That is what, which is the required half range Fourier cosine series. As you can notice, this series contains only cosine terms. Okay, observe the intervals and the problem clearly. What is it exactly asking? Half range cosine or half range sine? Cosine series means you have to get only in the series cosine terms. Sine series means only you have to get only sine terms in the series. Okay, thank you.